Assalamu alaikum. In this lecture we are going to do some examples and we are going to classify soil as per unified soil classification system. So let us start with our first example. So this is our first example and we are going to uh, do the soil classification of soil A. So this is soil A. So that this biggest S-shaped curve is our soil A. This is the soil A that we are going to classify. One important thing here in this figure is that the grain size is increasing, the particle size is increasing in this direction. So in some books it is given in reverse direction, so it doesn't matter. So the particle size is increasing, that's why you see this S shape is in reverse direction. Anyway, let's start with it. So the very first step always when we are going to do this soil classification, either we get data in table form or it will be shown on the graph with the S shape. So here we have got the data on in the form of graphical S shape. So what we are going to do is first we have to look at what is the percentage of gravel, percentage of sand, and percentage of fine. So if you remember, for gravel, the upper limit is this 3-inch sieve and the lower limit is number 4 sieve, and for sand the lower limit is number 200 sieve. So this is gravel and this is sand. So if we look at where is number 3, this is our 3-inch sieve, this is number 3, and where is number 4, here is written number 4. So that is number 4. I'm drawing this yellow highlighting with this yellow line, yellow color. So this is number 200. So this is number 200. So what we are going to do is we are going to draw a horizontal line from 3-inch. So this value here is 98. Okay, so it means passing from 3-inch sieve is 98%. And from number 4 sieve, if I draw a line here, this is number 4 sieve, you go down, when we touch this S-shaped curve you go horizontal and see what is this value. When you read, this value is 62. So passing number 4 sieve is 62. And what is passing number 200 sieve? For that we have to draw a line from here. So this value is little less than 10, so I think it is close to 8 or 9. So let me take it as 8%. Now what is the percentage of gravel? So the percentage of gravel is going to be 98 minus 62. So 98 minus 62 is 36%. So you see, gravels are 36%. Sand is going to be 62 minus 8. So 62 minus 8 is 54%. So from here I can say that gravel is 98%, sand is 54%, and fines, they are always passing number 200, so we don't have to subtract anything. So fines are going to be 8%. Anything which is passing number 200 is fines. Now if we add this thing, it is not coming as 100%, it will come as 98%. Why it is 98%? Because everything is not passing from 3-inch sieve. If you look here, from 3-inch sieve passing is 98%, means there are 2% particles which are bigger than 3-inch, and that are actually cobbles. So here in this soil the cobbles count 2% of the weight, but we are not going to use this. In classification, cobbles are not used. Anyway, I just wanted to show you that here the sum is not coming as 100, and the reason why it is not coming 100 is because there are 2% cobbles. So yes, if you add 2% cobbles, now we have got 100%. This percentage is coming. Now we might need to use CU and CC. For CU and CC, you know how to calculate. We have to draw a line for 60% So if you draw a line from 60% like this, and from there if you go down, so that value is going to be D60. So if you read from here, this is 1, 2, 3, 4, and it's a little bit higher than 4, so I have taken this as 4.2. How can I find D30? So you have to draw a line from 30%, go horizontal till we reach this curve, and then we go down. So this value is the D30. How much is this 30? This is 0.1, 0.2, 0.3, 0.4, 0.5, and this is 0.6. And 10%, you just draw a line from 10%. Okay, and when we touch this curve, we come down. So this is D10. So this is 0.09%. So if you divide those ratios, if you remember, CU is D60 by D10. So if you divide this, this will come as CU is going to come as 46.67, 46.7, and you can also calculate CC. One more information is given to us in this example, and that is the liquid limit, which is 42, and plastic limit. Remember, this is very important. This is plastic limit, not plasticity index. It is 31. So what will be plasticity index? It's a difference of liquid limit and plastic limit. Liquid limit minus plastic limit, it will come as 11. Now we have to look at if we are going to plot above a line or below a line. So you can use this graph. So suppose this is 42. You just draw a line, vertical line, and then look where is 11. It's very close to 10, and just draw a horizontal line and see where both of those lines are going to intersect. So it's very clear that it is below a line, but there are some situations when we are going to be very close to line, and sometimes it is difficult to guess if that point is on the line, above a line, or below line. For that reason, it's always a good idea to use this equation of a line. So let me write value of pi on a line, pi subscript a line. If you remember, the formula is 0.73, liquid limit minus 20. Now liquid limit is 42, so this is going to be 0.73, 42 minus 20. So this comes as okay, 16.02. Means if we are on a line, then against the value of liquid limit of 42, pi is going to be 16.2. Now what is our value? The value of pi, the calculated value from the soil, this value is 11, which is less than 16.2. So because we are less than 16.2 means we are below a line. So it's very simple. If this value was more than, then we would have been above a line. But in this case, 11 is less than 16.2, so we are below a line. Okay, on a line or above a line is clay, below a line is going to be silt. So we are below a line, so the letter is going to be M. Now we have to look at the second letter. It will be either L or H. So we use L if liquid limit is less than 50. Remember, our liquid limit is 42, which is less than 50. So the fines actually in this soil are lean silt or low plasticity silt. Okay. So this is now clear. So let me here summarize. So in our case, in this example, gravels are 36%, sand is 54%, fines are 8%, and liquid limit is equal to 42 and plasticity index is equal to 11. It tells us that on P chart that it is actually, the fines are actually a low plasticity silt. Okay, now We have to first look at what is passing 200. Remember, passing 200 are the fines. How much is passing 200? It is 8%. And because it is less than 50%, means these soils that we are dealing with are coarse grained soils. Coarse grained soils, right? This is the very first step that we have to look at. Okay, now whenever the remember one more thing that you should keep in mind, that whenever passing 200 or fines are less than 12%, we are going to need CU and CC. So CU and CC are required. But if the value of fines is more than 12%, we do not need. So sometimes students calculate CUCC, they spend some time on that, but later on when they go into the table, there is no need. So that's why keep in mind, if fines are less than 12%, you should in the beginning calculate CUCC. If they are more than 12%, no need to calculate, because you are not going to need it on the table, on that table that we are going to see on that graph. Okay, so we know that now. Here the gravels are 36 and sand is 54. So because here we see that sand is more than gravel, so predominantly these are sands. Okay, so we are going to go now onto this chart. This is for coarse grained soils. This is a chart for coarse grained soils, and I have summarized here. Gravel is 36, sand is 54. So here we know that sand is more than gravel. So because sand is more than gravel, we are going to start here. Sand is more than gravel. Now the next thing is we have to look at, there are three choices. Fines are less than 5%, they are between 5 and 12%, and they are more than 12%. In our case, fines are 8%. So we are going to go in this middle line. Now here we have two options. CU is more than 6 or CU is less than 6. So in our case, CU is 46 and CC is 0.95. I mean 0.95 means it's very close to 1. So I can even take it 1. So we are going to go up because our CU value is more than 6. Now there are two paths. One is ML and the second one is ML, MH, and second one is CL and CH. But in our case, when we saw on P chart, it was plotting below a line. So the fines are actually silts of low plasticity. So we are going to go like this. So this is actually a dual classification, SWSM. So if I just look at this SWSM, it says that it is a well-graded sand with some silt. Now there are again two choices. Gravels are less than 15% or more than 15%. In our case, gravels are 36%, which is more than 15. So we will go down, and this is our classification. So what is the classification? Classification is well-graded sand with silt and gravel. If you can read it here, what I have written here in big font. So this is actually the description. So the soil is SWSM. So when I just read this SWSM, I can get an idea that it is well-graded sand containing some silt. But if you read here, it is well-graded sand with silt and gravel. You see, that information of gravel is not there in this symbol. So that's why you have to go through this whole process, and this is the complete description. So this is the complete description of the soil according to Unified Soil Classification System. So our first example was coarse grained soil. Now we move on to second example. So here we are going to take soil A in this table. So here in this table there are A, B, C, D, E different soils. I'm going to do this with first soil A. So here if you look at, there is no chart given, there is no gradation curve shown here. So instead of showing this gradation curve, data from gradation curve is summarized in the form of table. So the soil A passing number 4 is 80%. Where is number 3 inch sieve? You see 3 inch sieve data is not given. It's understood if 80% of the soil is going to pass from number 4 sieve, means 100% is going to pass from 3 inch sieve. 75 millimeter or 3 inch opening is very big, everything is going to pass through. So let me here, if you forget, it's always a good idea to draw these lines, and then here we can write 3-inch sieve, number 4 sieve, and number 200 sieve. And this is gravels, sand, anything is going to pass from number 2 is fines. So the passing from 3-inch sieve is 100%. Passing from number 4 sieve is 80%, and passing from number 200 sieve is 52%. You see, this time it is more than 50. So our gravels are going to be 100 minus 80, which is 20. 20% gravels. Sand is going to be 80 minus 52. 80 minus 52. So this is going to be 28%. And the fines are whatever is passing from number 200 sieve is 52%. So if we summarize here, gravels are 20%, sands are 28%, and fines are 52%. So if we sum up, it is 100%. Now, because passing number 200 is more than 50, so if you look here, passing number 200 sieve, which is equal to this is equal to 52%, is more than 50%. If it is less than 50, then it is coarse grain, but here it is more than 50, so it is fine grained soil. Fine grained soil. So the soil A given in this table is fine grained soil. Now there is a liquid limit and plasticity index given. Look here, important, this is not plastic limit, this is plasticity index. So already that subtraction has been done. So liquid limit is 30, plasticity index is 8. So let's look at where it is going to plot. So if we do this on the graph, we will see that this is very close to a line. So sometimes it is so close that it is difficult to guess if we are above or below a line. So I'm going to take the help of this equation. Plasticity index of a line is going to be equal to 0.73, liquid limit minus 20. So this is 0.73, liquid limit is 30 minus 20. So when we simplify this, it comes as 7.3. Now we have to look at what is our PI value. The value of PI is 8. Now this time 8 is more than 7.3. You see, now you see on a line the value is 7.3, but our value from the test result is 8. So it means we are above a line. So since we are above a line and the liquid limit is 30, which is less than 50, so the soil is going to be Cl. So our soil is going to be Cl. So because we are dealing with the fine grained soils, we are going to look at this chart of fine grained soil. So there are two possibilities: liquid limit less than 50, liquid limit more than 50. We are going to start from here because the liquid limit is 30, which is less than 50. So we are always going to be dealing with inorganic unless there is an organic soil. Now here there are three possibilities. Plasticity index is more than 7 and it plots above a line. We know that it plots above a line, so it means we are going to go like this. Actually our soil is lean clay, but now we have to look at some more details. Now there are two options here. One, it is written less than 30% plus number 200, and if you remember, I told you in my last class, this plus number 200 means we are talking about retained number 200. So whenever there is written plus number 200, it means we are talking about R200. So if you go back and see, our passing number 200 sieve is 52%. So fines are actually passing Passing is 52%. If passing is 52%, what is going to be retained? As I told you, passing plus retained is always 100, so it is going to be 100 minus 52. So 48% of the soil is going to stay on this sieve, and 52% is going to pass through this sieve of 200 number. So retained is 48%. So because in this case retained 200 is 48%, and this 48% is going to be more than 30, so we are going to go on this line. Now here again we have two choices: sand is more than gravel or sand is less than gravel. So look here, gravel is 20, sand is 28, so definitely sand is more than gravel. Again there are two choices: gravels are less than 15 or gravel are more than 15. So gravels are 20, so they are more than 15. So this is how you keep on going, and this is our classification. So it is lean clay, but the description is sandy lean clay with gravel. Sandy lean clay with gravel. This is the complete description. Symbol is Cl. If I just look at the symbol and if I don't go through this whole process, Cl means lean clay, but it is sandy lean clay with gravel. It is a lean clay, but it has got some percentage of sand and it has got some percentage of gravel. Okay, so we have done now two examples, one with coarse grained soil and one with fine grained soil. Now let's look at example number 3. So in this example I'm going to consider the same table, but I'm going to take now soil B. So this is our soil B. So same way we are going to draw these lines. So this is 3-inch sieve, number 4 sieve, and number 200 sieve. So at 3-inch the passing is 79%, and from number 4 sieve from 3-inch it is 100%. This 79 is from number 4, so 100% is going to pass from number 3, 79% is going to pass from number 4, and 45% is going to pass from number 200. So our gravels are going to be 100 minus 79, which is equal to 21%, and the sand is going to be 79 minus 45, which is going to be equal to 34%. And the fines are always passing number 200 sieve, and this is equal to 45%. So here is a summary: gravels are 21%, sands are 34%, and fines are 45%. This time fines are less than 50, so it means this soil is coarse grained soil, this soil B is coarse grained soil. But remember, fines are 45. This fines are P200, they are greater than 5%. So it means whenever they are greater than 5%, we need liquid limit and plastic limit. Yes, we have to carry out the test of liquid limit and plastic limit. So that's why these values are given: liquid limit, plasticity index 26 and 4. So let's look at it, 26 and 4. So in usual way we are going to calculate what is plasticity index of A line. So plasticity index of A line is going to be 0.73, liquid limit minus 20, so this is 0.73, 26 minus 20. Okay, so this value is going to be equal to 4.33. So the value of Pi of the soil is 4, which is less than 4.33. This time again you see it is very close. It's very difficult to see through the graph. If you are little careless, you might end up in a wrong region. So it means this is below A line. We are below A line, liquid limit is less than 26, so it means the soils which are fine grained, they are emelting. Okay, So those fines are predominantly lean silt, not the clay. Now we are going to go through the go through the uh, through this graph. Okay, I'm going to summarize the gravels we calculated as 21%, sands we calculated as 34%, and the fines were 45%. And when we checked it on the P chart, it was ml. The fines are actually, these fines are ml. Now let's start from where we're going to start from, gravel or from sand. So we have to look at which one is more. Gravel is 21, sand is 34. Means sand is more than gravel. So here this time we are going to start from sand. Now we have three options. What is the percentage of fines? It is 45%, which is definitely more than 12. Again, there are three choices. One is ml, mh, cl, ch, and then third one is cl-ml. But in our case, the fines are lean silt. So we are going to go through this top. So our soil classification is SM. So this soil is SM. Now again, we have two categories here. One is percentage of gravels less than 15%, and the second case equal to or greater than 15%. So the gravels are 21%. So we are going to go to here, which is more than 15. So the soil classification here is silty sand with gravel. So our classification is SM, and it is silty sand with gravel. So this soil in our example number 3 is silty sand with gravel, and the symbol is SM. Okay, let's move on to the next example. Okay, here I'm going to take this soil soil B shown here. This is soil B. So let me highlight this soil. So this is actually their soil. This soil B. Okay. So what is the first step? We have to look at the passing from 3-inch sieve, then from number 4 sieve, and then from number 200 sieve. The first one is gravel, second one is sand, and the third one is fines. Okay, look at 3-inch sieve. So the curve is touching it at the top, so it means it is 100%. Okay, so the value here is 100%. Now at number 4 sieve, this is number 4. If I come down, okay, and if I draw here a horizontal line from here, if I go like this, so it is going to be 62%. The third one is number 200C. This is number 200. See, this is number 200C. If I go down and I will reach here, the curve is just very close to 0. So I'm going to take this value as 0. There is no fines, 0%. Because fines are now 0%, there is no need to carry out liquid limit and plastic limit test. So gravel is going to be 100 minus 62, which is equal to 38%. Sands are 62 minus 0, which is 62%, and fines are 0%. There are no fines in it. So here is the summary. Gravel is 38, sand is 62, fines are 0, and passing number 200 is less than 50 definitely. So it is a coarse grained soil, because let me write somewhere here, passing number 200 is less than 50. So our soil is going to be coarse grained soil. So we have to look at coarse grained table. One more thing, because the fines are less than 5%, if they are less than 12%, we have to carry out CU and CC. So you can check yourself. I have already calculated CU and CC. And by the way, this page is from the chapter of mechanical analysis. If you see that chapter of mechanical analysis, if you see that chapter of mechanical analysis, you are going to find out this graph over there. So CU and CC is given 13 and 0.83. And why it is not 1? Because when we are going to read, there might be some error in accurately reading the values on the graph. Actually, it is close to 1. So if I round off, I can say it is 1. Okay, and look at CU is very high. It's a well graded granular soil. Okay, now we are going to go through this chart. So let me write here the percentage of gravels. It was 38. Sand is 62. Fines are 0. Okay, CU and CC. CC is almost 1, but CU was 13. So CU is 13. So let's look at sand is 62. So we are going to start from here. Sand is more than gravel, and fines are 0%, means less than 5%. So we are going to go like this. Okay, CU value is 13, definitely is more than 6. So it's a well graded sand. Now we have to look at what is the percentage of gravels. 38, more than 15. So this second line is our classification. So this is the classification. It is well graded sand with gravel. It is SW, well graded sand with gravel. So this is our classification. Well graded sand with gravel. Okay, let us do one more example, and this is going to be, hopefully, I think, let me see if it is our last example. So let's do this example. So here is our next example 5, today's 5th example, and we are going to look at soil C in this figure. So this is soil C. This is soil C. This soil C we are going to consider. Okay, so let's start. So the first thing is we have to see what are the passing from these 3 sieves. 3-inch sieve, number 4, and number 200. So let's look at. Okay, so remember the curve here is touching at 100, and from there it is going like this. It is going like this, and this is actually our S shape. And when it reaches here, then it goes like this. And remember, those horizontal portions, these are the particle size that are missing. They are not in this soil, they are absent. So what is the value here? So if you look here, the value at 3-inch sieve is 100. What is the value at number 4 sieve? 100. What is the value at number 200 sieve? 0. So let me write here these values. So this value here is 100%, 100%, 0%. So it means gravels is going to be 100 minus 100, 0%. And sand is going to be 100 minus 0, 100%. And the fines, passing number 200 is 0%. So if you look at the gravels are 0%, there is no gravel in it, it's pure sand, 100% sand. And fines is 0%, they are less than 50, so it is coarse grained soil. The fines are less than 5%. We don't need liquid limit, plastic limit. These are non-plastic soil. This is a non-plastic soil, means we cannot perform liquid limit, plastic limit. Even if you take this soil and you want to do this test, you will not get any results. Okay, so the next thing is we have to do the liquid limit, Cu and Cc. It's already calculated here. You can try yourself. Cu value is very small. Cc is close to 1. Now we are ready to go to that chart and let's classify this soil. So let me summarize here. Gravels are 0, sand is 100, fines are 0, Cu is 1.63, and Cc was 0.96, which I can take it on. Okay. So it's all sand. Sands are greater than gravel. We will go up because there are fines are less than 5%. It is 0, and our Cu value is this time less than 6. It is 1.63. So we will go like this, and the soil is actually poorly graded sand, or it is uniformly graded sand. Now there are two options here: gravels less than 15 or more than. There is no gravel here, it is 0%. So if I go horizontally, if I go like this, actually the soil classification is poorly graded sand. So it is SP, poorly graded sand. So this time there is no gravel in it. So this is poorly graded sand. So this is our example number 5 of today. So we have seen today 5 examples. Some cases were fine grained soil, some cases were coarse grained soil, and there was one case where it was dual classification. So we have seen almost all different possible cases, and remember, it doesn't take more than 10 minutes in classifying these questions. They are not difficult, you just have to do practice. So I'm going to give you, if you see the class notes, if you see those lecture slides, there are a lot of examples, so you should try yourself. So today I discussed two soils, A and B. So you can try yourself the soil number C, D and E, and also you can try these soils as well. So soil A, D, C, E, still you can try yourself. You can get this data from the chapter of sieve analysis or mechanical analysis. So please practice these questions. Thank you so much and have a great day.